Hello friends, my topic is subcellular fractionation, design and working of analytical ultracentrifuges, sedimentation velocity and sedimentation equilibrium analysis. Subcellular fractionation, it refers to disintegrating intact cells into their integral parts, the cellular organelles. Its objective is to isolate each cellular organelles to a high degree of purity. The technology of subcellular fractionation was introduced by the Christian Didier, Camillo Golgi, and George Palade. There are two methods to perform subcellular fractionation using centrifugation. The first one is differential centrifugation and the other is equilibrium density centrifugation. Differential centrifugation. Subcellular components or organelles vary in physical parameters such as mass, size, and density. Differential centrifugation exploits the sedimentation behavior of particles varying in their densities. The particles are separated based on their differential sedimentation velocities in a medium of considerably small density and low viscosity. The differential centrifugation led to separation of cellular lysate into a pellet and a supernatant fraction. Equilibrium density centrifugation. It's also called gradient centrifugation. It separates cellular components that have closely related densities. A non-ionic medium of low density is chosen. Design and working of analytical ultracentrifuges. The ultracentrifuges that are used for the analysis of various particles present in the sample. These ultracentrifuges have detection systems to monitor the spinning and position of the particles in real time to determine the sedimentation coefficient that aid in the analysis of particles based on shape, size, and masses. Analytical ultracentrifugation for the determination of the relative molecular mass of a macromolecule. Three optical systems are available for the analytical centrifuge. One of the examples of the detection system used in ultracentrifuge is the Schlieren optical system. Analytical ultracentrifuge is mostly commonly used for the determination of properties of biomolecules like proteins and nucleic acids. Steps of analytical centrifugation. Small sample sizes are taken in analytical cells to be placed inside the ultracentrifuge. The ultracentrifuge is then operated so that the centrifugal force causes a migration of the randomly distributed biomolecules through the solvent radially outwards from the center of rotation. The distance of the molecule from the center is determined through the Schlieren optical system. A graph is drawn from the solute concentration versus the squared radial distance from the center of rotation, based on which the molecular mass is determined. Sedimentation velocity and sedimentation equilibrium analysis. In sedimentation velocity, the movement of solutes in high centrifugal field is interrupted using hydrodynamic theory to define the size, shape, and interaction of macromolecules. Sedimentation velocity to determine the homogeneity of a sample and define whether it undergoes concentration dependent association reactions. Sedimentation equilibrium is a thermodynamic method where equilibrium concentration gradients at lower centrifugal field are analyzed to define molecule mass, assembly stoichiometry, association constants, and solution non-ideally. Thank you.